And we're back. I actually just recorded this video, but my laptop froze up right after I finished it, so this is take two. In this section, we're going to look at the unit circle, which is really important for trigonometry and this year and the following years. So how to read this is, if you have a given angle, let's say sine of theta, if you know an angle, then sine is equal to the y-coordinate at that angle. Cosine is equal to the x-coordinate at that angle, and tangent of some angle is equal to y divided by x. So the y-coordinate divided by the x-coordinate, or sine divided by cosine. Let's try a few examples. So we have sine of pi over 6, or 30 degrees. We look at our unit circle, find 30 degrees, pi over 6, and sine is equal to the y-coordinate. So sine at pi over 6 is equal to 1/2. Okay, let's try cosine of 90 degrees. Look at our unit circle, find 90 degrees, or pi over 2. Cosine is the x-coordinate, so cosine at 90 degrees is equal to 0. Then let's try a tangent. So tangent of, let's say, 5 pi over 6. Find 5 pi over 6. Tangent is equal to y divided by x, so that's going to give us 1/2 divided by negative radical 3 over 2. To divide fractions, multiply by the reciprocal, so multiply by negative 2 over radical 3. You can cross cancel the 2's, leaving you with negative 1 over radical 3. And then multiply by radical 3 over radical 3 to get the square root out of the denominator. So you have tangent of 5 pi over 6 is equal to negative root 3 over 3. But what about angles that are not on the circle? So, for example, cosine of negative 2 pi over 3. Well, the best way to think about this is take a look at the positive 2 pi over 3. Positive 2 pi over 3 would be here, and negative 2 pi over 3 is just going the opposite direction because it's negative. So really negative 2 pi over 3 shows up on the unit circle as 4 pi over 3, but that's negative 2 pi over 3. And since cosine is just the x-coordinate, we can say that's equal to 1/2. Let's try another one. Let's try sine of 7 pi over 3. Now that should already look familiar to you since we know that going around the circle once is equal to 2 pi. So picture it. This has to go around 2 pi, or we could say that's 6 pi over 3, right? Because 2 pi is the same as 6 pi over 3. And then we have to go another pi over 3 and end up here at pi over 3. Or, as this problem likes, 7 pi over 3. Sine is the y-coordinate, so we would write sine of 7 pi over 3 is equal to square root of 3 over 2. The last thing what I want to talk about is how this is actually just a circle imposed on an xy grid. So it's not random that some of the values are negative and some of the values are positive. That's just where they fall in actual space on an xy grid. So it makes sense that all the coordinates in the first quadrant are positive, the x-coordinate is negative, and the y-coordinate is positive in the second quadrant because you have to go left and then up to hit these points. So you go left negative and then up positive. Everything's negative down here in the third quadrant, and the x-coordinate is positive and the y-coordinate is negative in the fourth quadrant. So what of this unit circle do you need to know? Well, you need to memorize these main four, but it helps when you remember these are actually just on an xy grid. You go over 1 and then comma 0. 0, comma 1, negative 1, comma 0 on the left, and then down here we have 0, comma negative 1. So those are four that you need to memorize. It shouldn't be that hard. And then the last things you need to memorize are these three. What pi over 6 or 30 degrees is, what pi over 4 or 45 degrees is, square root 2 over 2, comma square root 2 over 2, and what square root 3 is. However, Once you memorize these, you can really know the rest of these because you just change the x and y values to be positive or negative depending on what quadrant they're in. So really, if you memorize these four, so these four, and these three, then you've got the whole unit circle memorized.